Hello, my name is Walter Ellsworth, and welcome to Physics 2212, Lab 2, Lines of Charge. The purpose of this lab was to use the previously made observations between the two pieces of charge tape and make a more accurate model and mapping them more as lines, and then using that instead of treating them as point charges. Each strip in the models for this lab, each strip of charge tape is divided into equal segments, and then each segment was then treated as an individual point charge with equal charge. And the equations that I used were the electric field of a point charge, the electric force, the equation for superposition, which is just E net, Newton's second law to calculate the force of gravity, which was the countering force, and then the force of levitation was opposite of that, and then Newton's third law, which proved that of levitation of every force has an opposite equal reaction. The details of the experiment were the same as last time to create the tapes. A piece of tape was stuck and smoothed down to the desk, and then tape A was laid on top of that piece and then quickly pulled away. The tape was then hoped to be charged, and it was hung freely, and various objects were brought near it. I noticed that the tape was attracted to negatively charged objects like the pen that I had in my hand. So that proved that it had to have a negative charge. And then in the initial and then when I did the same thing with the other tape and brought the two together, they repelled each other, so that it was attracted to the negative thing, so it's a positive charge. It's my bad. And when the process was repeated, the other tape repelled, so they both had a positive charge. My bad. All three tapes were neutral to begin with in the initial conditions, and then they were charged after the process of pulling them off the original tape on the desk. And in the system surroundings, the top tape, tape B, as you can see on the diagram to the right, acted as the system, and then the other tape, my hands, everything else were the surroundings. Um, the assumptions in this lab were that air resistance was ignored and that the U tape, each one was about the same charge as the other one I made. And I assumed too that the charge was evenly distributed across the entire length. The newly calculated charge I had from this model was 2.215 times 10 to the negative 8 coulombs. And the force of gravity I calculated was 1.96 times 10 to the negative 3 newtons. The conclusion from these results was that using the principle of superposition was that E net produces a much more accurate model of what's occurring between the two tapes than when treating them as just two large point charges, basically, and treating them as almost like an integral of charges. Uh, and then a thing to note is when experimenting with the number of segments, the more segments I use, the closer to the Q calculated in the model Q were, which makes sense. The results of this lab were using the equation for the force of the electric field and solving for Q, knowing that the force of gravity and the force of the electric field must have been equal. I calculated the following E field of 2.215 times 10 to the negative 8 coulombs. And then by guessing and checking the computation model, a Q value of 2.77 times 10 to the negative 8 was found to be. And then these are the constants on the left. On the right, this is the equation for the E field and all the constants that are used in that, and then the function for the line charge. This is top tape and bottom tape held as the model in the model. This is to calculate the force, and then this is the model I was able to calculate. I tried to use as many spaces, as many sections as possible to get a really accurate model. The personal errors could have been my calculations, and the assumptions that I used may have been incorrect. The charge may not have been evenly distributed across the surface of the tape too. It was just a very easy assumption to disprove, and the charges may not have been equal between the two tapes. And the line charge was measured using a finite number of sections, when in reality you would use an integral and you would take as an infinite amount of sections, and as we've done in class. And for the discussion, what if I had modeled the tapes as single point charges like in the previous lab? The model would have been much less accurate if modeled as single point charges, as you can see. the discrepancy between these two, and these estimates are different because the tapes are not point charges. The tapes are a line charge with and it's divided into a large number of segments, and then as the segments approach infinity, you get more and more accurate. So treating it as one is just not accurate at all. Thank you.